Hey everybody. Today we're solving inequalities involving absolute values. These sorts of inequalities are always solved using just a couple of facts. First of all, if you have the absolute value of something less than c, then that something has to be between negative c and positive c. Here, by the way, we're assuming c is positive. Secondly, if you have the absolute value of a function is greater than c, then either that function is greater than c or it's less than negative c. We can replace less than with less than or equal here, and we can replace the greater than with greater than or equal, and the facts are still true. I think pictures are very helpful here. We think about the absolute value of x as the distance from x to 0. So absolute value of x less than c means all the points that are within c of 0, not including c itself. That's pictured there on the left, basically values that are close to 0. On the right, absolute value of x greater than c, we're saying we want the points that are further away from 0 than c. And of course that can happen to the right and to the left. It can happen in two different ways. Hence we're getting x greater than c and x less than negative c. Let's do a couple of examples. First of all, absolute value of 3 times the quantity x minus 2 over 5 less than or equal to 6. So this is the first sort of inequality that we had on that first slide. It's going to get broken up like this. Negative 6 less than or equal to what's inside, less than or equal to positive 6. We call this a compound inequality because there really are two inequalities going on here. Next, I want to solve so that I have x alone in the middle. I'm going to multiply the whole thing by 5/3, multiply by 5 and divide by 3. And then I'm going to add 2 to each piece of this inequality. I get negative 8 less than or equal to x less than or equal to 12. We can write that in interval notation as the closed interval negative 8 comma 12. Those square brackets indicating that the endpoints are included in our interval. Example 2, negative 2 times the absolute value of 3x plus 5 plus 7 less than negative 13. Our process here is to isolate the absolute value, get it alone, and then rewrite the problem using a compound inequality from that first slide. We start by subtracting 7 from both sides, and then divide by 2. Now remember, when you multiply or divide an inequality by a negative number, you have to change the sense of the inequality. So the less than here becomes a greater than. Okay, so the absolute value of something is greater than 10, so either the something is greater than 10 or it's less than negative 10. I'm going to solve each of these the same way, subtracting 5 from both sides of each of those inequalities, and then dividing by 3. So x is greater than 5/3 or less than negative 5. Let's finish by writing this in interval notation. Here we're going to need two intervals. X greater than 5/3 is going to be parenthesis 5/3 comma infinity with another parenthesis. And x less than negative 5 will be negative infinity comma negative 5, again with round parentheses. We connect those two with the union, sort of a rounded off U symbol. Overall, we get negative infinity comma negative 5, union 5/3 comma infinity, round parentheses all the way across, indicating that none of the endpoints are included.